Neural network architectures. AI intermediate level. Introduction. Neural networks are powerful machine learning models used to detect patterns in data. They power many artificial intelligence applications such as image recognition, speech recognition, language translation, recommendation systems, autonomous vehicles. However, different types of problems require different neural network designs. The structure and organization of neurons in a neural network is called its architecture. A neural network architecture determines how layers are arranged, how neurons are connected, how information flows through the model. Different architectures are designed to solve different types of AI problems. Understanding neural network architectures is essential for learning deep learning and advanced AI systems. What is a neural network architecture? A neural network architecture refers to the structure of a neural network. It defines how the layers and neurons are organized and connected. In simple terms, neural network architecture equals the design or layout of a neural network model. Example concept. Input layer means hidden layers means output layer. The architecture determines how data moves through the network and how the model learns patterns. Why neural network architectures are important. Different types of data require different architectures. For example, images contain spatial patterns. Text contains sequential patterns. Time series data contains temporal patterns. Example concept. Different data types means different neural network architectures. Choosing the right architecture improves model accuracy, training efficiency, ability to learn complex features. Basic neural network architecture. The simplest neural network architecture consists of three main layers. Input layer receives raw data. Examples: image pixels, numerical features, text embeddings. Example concept. Dataset means input layer. Hidden layers. Hidden layers process the data and detect patterns. Each neuron performs a mathematical transformation. Example concept. Input means hidden layers detect features. Deep learning models contain many hidden layers. Output layer produces the final prediction. Examples: classification result, numerical prediction, probability distribution. Example concept. Hidden layers means prediction output. Feedforward neural network. FNN. The feedforward neural network is the simplest architecture. Information moves in one direction only. Example concept. Input means hidden layers means output. Characteristics. No cycles in the network. Simple architecture. Used for basic machine learning tasks. Applications include regression problems, simple classification tasks, convolutional neural networks. CNN. Convolutional neural networks, CNNs, are designed for image processing. They detect spatial patterns in images. Example concept. Image means convolution layers means feature maps means classification. Key components include convolution layers, pooling layers, fully connected layers. Applications include facial recognition, object detection, medical imaging. CNNs are widely used in computer vision. Recurrent neural networks, RNN. Recurrent neural networks, RNNs, are designed for sequential data. They remember previous inputs when processing new inputs. Example concept. Word sequence means RNN means language prediction. RNNs are useful for language modeling, speech recognition, time series forecasting. However, traditional RNNs suffer from vanishing gradient problems. Long short-term memory, LSTM. LSTM networks are an improved version of RNNs. They are designed to remember information for longer periods. Example concept. Text sequence means LSTM means context-aware prediction. Applications include machine translation, speech recognition, time series prediction. LSTM networks help solve the long-term dependency problem in sequential data. Transformer architecture. The transformer architecture is one of the most important modern neural network designs. Transformers use a mechanism called attention to process sequences. Example concept. Text input means attention, mechanism means language understanding. Transformers power many modern AI systems such as language models, chatbots, translation systems. They are widely used in natural language processing. Graph neural networks. GNN. Graph neural networks are designed to work with graph-structured data. Example concept. Nodes plus relationships means graph neural network means prediction. Applications include social network analysis, recommendation systems, fraud detection, autoencoders. Autoencoders are neural networks designed for data compression and feature learning. Example concept. Input data means compressed representation means reconstructed output. Applications include anomaly detection, dimensionality reduction, image denoising. Neural network architecture workflow. Designing a neural network architecture typically involves define input data, down pointing arrow, choose architecture type, down pointing arrow, design network layers, down pointing arrow, train model, down pointing arrow, evaluate performance. The architecture plays a major role in model performance. Real-world applications. Different neural network architectures power many AI systems. Computer vision. CNNs used for object detection and image classification. Natural language processing. Transformers used for translation and chatbots. Speech recognition. RNN and LSTM used for audio sequence modeling. Recommendation systems. Graph neural networks analyze user relationships. Healthcare. Neural networks analyze medical images and patient data. Advantages of neural network architectures. Different architectures provide powerful capabilities. Advantages include ability to handle different data types, scalable deep learning models, improved pattern recognition, high performance on complex problems. Example concept. Proper architecture means improved AI performance. Limitations and challenges. Designing neural network architectures also has challenges. Challenges include choosing the correct architecture, high computational cost, large data requirements, long training times. Example concept. Complex architecture means high computation requirement. Concepts learned from neural network architectures. Understanding neural network architectures helps learners understand. Checkmark how different neural networks are structured. Checkmark how deep learning models process different types of data. Checkmark how AI systems solve complex problems. Checkmark how architecture affects model performance. Checkmark how modern AI systems are designed. Neural network architectures form the foundation of modern deep learning systems. Simple definition. Neural network architecture. The structure and organization of layers and neurons in a neural network. Final summary. Neural network architectures define how neurons and layers are organized in a neural network. Different architectures are designed to handle different types of data and problems. Examples include feedforward networks, convolutional neural networks, recurrent neural networks, transformers, and graph neural networks. Choosing the right architecture is essential for building effective deep learning models. Understanding neural network architectures is a key step toward mastering deep learning and artificial intelligence development.